I welcome you on this lesson, coordinate geometry. We discussed coordinate geometry previously in one of the lessons that Mr. Chigos did. I'm going to continue taking you in coordinate geometry, me teacher Musana, Seremba Online School. Senior 3, please, you can enjoy the lesson, but make sure that you study but also doing the work. And on addition, such that you should practice several questions. Make sure you look at the question bank, look at different books, and be able to come up with what? A lot of practice makes you to be perfect. Don't be always doing one number, sitting, and don't doing more numbers. It's going to cost you, and it will not be effective to us and to you. So in coordinate geometry, you'll learn about, or you have discussed already, gradient, length of the line segment, midpoint. We shall look at equation of a line, parallel and perpendicular lines basically. Now to review for some of you that you watched in the first lessons, gradient, basically coordinate geometry also has that part which we are not going to repeat. That is the first part in senior 1, where you plotted the x, y. You know, when you are plotting a point, we mean if you have a point 2, 4, then this means this is the x, this is y. Should you change, you are writing another point, because x, y is not the same as y, x, no, unless these two values are symmetrical. What do you mean by symmetrical? Because this is cardinality. So unless the point is 2, 2, so even if you reverse it, it's the same as 2, 2. But if the point is 2, 3, and you reverse it, you write 3, 2, it is not the same, it will be wrong. So you should know that. So in this case, plotting points in senior 1 and then other things are not going to repeat. You should be knowing that. Our emphasis is going to be mainly on these few concepts. That is gradient. You know, by now you must know how to get the gradient of a line. How do you get the gradient of a line? So we said gradient m is y2 minus y1 over x2 minus x1. That's how we get the gradient. So the gradient is given by this formula. So once you know that, you'll be able to get the gradient, and these are points. For example, if I give you 2 points, p is 2, 4, 2, 4, 2, and then q maybe 3, 1, and I ask you to get the gradient, then you'll call this x1, y1, x2, y2, substitute that formula, then you have our gradient as what? As, make sure you substitute correctly. Even if there are some sign negative, positive, make sure the formula is also written correctly. Most of you write this formula and you, instead of writing x2, y2 minus y1, you end up writing x2 minus x1. That is wrong. Don't interchange the formula. Is it okay? Yes, so in this case, we have that. So we can just substitute. This is our y2, which is 1, minus our y1, which is 2, over our x2, which is 3, minus this, which is 4. So this gives you negative 1 over negative 1, which is a 1. So that becomes the gradient. Good. In the next lesson, or in the lesson which Mr. Chigosi did, he found out how to get the length of the line segment. We said that in case you want to get the length of the line segment, for example, I have P. You know, a line segment is the distance between two points. So I have 2 points, P, and then what? Q. So this P, if this is x1, y1, and this is x2, then y2, if I want to get the length of this line segment between these 2 points, it could be the length of a line, so long as these are end points. If these are the end points, also we can call it the length of a line. These points are the extreme, so you can get the length of that line. We said you can get this by using the formula, the modulus of PQ, whereby this means the length of a line is equal to, so the square root of, you get x1 minus x2, but you square, plus y1 minus y2, but you square. This is how we get the length of the line what? Segment. If they ask you to find the length of the line segment, you should be able to compute it that using that approach. Like in these examples here, we may find the length of this, one of them. So we said, solution, find the length of the line segment with the following points. The cameraman can show it clear there. It is negative 8, 2, and the q, which is 4, 7. So I just substitute, I call this one x1, y1, x2, y2. Simple. So you call the length of the line segment PQ, denote it by that. It will be equal to the square root of, so can you put, this is, take note of the formula. Some of you add instead of subtracting. That's where the problem will be. If you add this and you add, you will fail. And when you fail, there is no marks given for a person who has failed. And there is no marks for formula. That for you write correct formula, but you failed the computation. That's all wrong. So you should write, this is 4, minus, this is now 1, which is minus, this becomes a plus. Take note of the integers squared. So then plus, you get, this is x, y1, which is a 2 minus a 7. So when you do this, so it is the square root of, this is 12, very good, squared plus, subtract this, that is negative what? 5, that's good. So when you take the square root, 12 is 144 plus 25. What do you get? That is 169, which is 13 units. So that is the answer. You could be able to compute that. The length of P, the length of this point from the origin. Now what does it mean? They mean that should you have that point, let me say I'm plotting this point here. This is x, this is y. Should I plot that point from the origin? That's like O. The position vector of that point. So the origin O, which is 0, 0. Take note of that. This is the origin. Should I plot that point from the origin? Maybe let me draw it there, such that the people can be able to see it clearly. Should I have this point P, which has the value 12k from the origin? Then this length here OP is what? Is 13. So what does it mean? It means the point, the end point between P and O is 0, 0 and 12. That's what means the length of P from the origin. Now this symbolizes that distance, this point OP is called the position vector. The point which describes a point, the position vector is called, or the position coordinate is that coordinate that describes that point from the origin. Otherwise, from here, for example, when you plot 12, you look for 12 at the x and you look for k at y, then you plot that point. So in this case, we are finding that. So, but how do we get OP? The length is given by, use the formula x1 minus x2 squared plus y1 minus y2 squared. So on doing this, so we are able to find this. So x1, 0, so we shall be able to compute, this is x1, which is 0, take note of that, x2, which is 12, plus, but don't forget square. What is y1? It is 0 minus k, which is that side. So when you do this, you get negative 12 squared. Put brackets. Brackets are punctuation marks in mathematics. The moment you don't put them, you'll be able to fail, because some of you, when you square this, you end up squaring 12 and you get negative 144, which is wrong. So you square that, plus k squared. So when you subtract, put in a bracket, negative k squared. So take note, this is now gonna be what? 144. So 144 plus k squared. Is it okay? So this one is equal to the length, which is 13. They have told us this is 13. So you say equals 13. So it implies that you have the square root of 144 plus k squared is equal to 13. To remove this square root, you did formula development, square both sides. So we shall have 144 k squared is equal to 169. Should you have that? So when you take that, I think this is 25, because when you take this and subtract, it will give you 25. So we get k squared is equal to 25. So take the square root and the answer is plus or minus 5. But now which one is the correct one? You can take both of them. So k is either 5 or minus. So we just need to be sure which one is giving us the answer. So sorry, the k is, take the square root on both sides, which is this, and then k becomes plus or minus 5. They said find the value of k, put all the two values there. That's how we find that. That's how we find that, because of that. So you can also see how we can find this, find the value of k, this, because it said find the distance, find the value of k if the distance between these 2 points is 3. So it is just simple. We are going to find that. We are going to find that. So we are just using the concept of distance. The concept of distance is very important. The concept of distance is what we are using. So you just mind about what they tell you. So you must have your calculators. So what is the distance between 2 points? Let me say this is P and Q. Let me call this point Q. So PQ modulus means length. So it will be x1 minus x2 u square plus y1 minus y2 u square. So what is the point? P is 4, 8, and Q is 1K. So label them correctly. Don't label them poorly. So it will be 13, 3 is the square root of, so you put x1, it is 4. You subtract y1. Y1 it is, so it is x1, which is this, yes, minus x2 in our formula. So 4 minus 1 is square. Y1, which is 8 minus k. 8 minus k, but is square. So what do we get here? 3 is equal to the root. This is what? 3, and that is 9 into 8 minus k, but you square that. So what do? You square both sides. So that to remove this root, class, to remove this root, you square both sides. So this will be 9 equals, when you square this, you get 9. So when you square, the root cancels. So you get 9 plus 8 minus k squared. So when you subtract this, it becomes 0. So 8 minus k, everything squared is what? 0. So you take the root on both sides, so that you can get 8 minus k squared is 0. So this one cancel, and then you get 8 minus k is 0. So our k is 8. So that's how we come up with that. So we have been able to use the concept of the line segment to find that. In the next lesson, we are going to look at the midpoint. Thank you.